thank you. So I first wanted to thank Martin for his excellent and expertise work organizing this workshop. Also want to thank Ladislav for his support and the Institute as well for making this conference possible. So thank you. All right, so my talk today is going to be largely programmatic in that I'm going to try to motivate a new conception of scientific explanation that I call the Eikonic conception. So I'm going to try to outline it in broad strokes, but I want to try to first motivate, I'm unfortunately slightly covering up the recording, try to motivate the need for this alternative conception by first reviewing some of the objections that have been raised against the ontic conception, so some of the problems that have emerged in recent years, articulated in recent years about this conception. And then I'm going to, being a practice-oriented philosopher of science, I'm going to try to look at a number of cases from across the sciences that I think also motivate the need for this alternative conception. And then finally, I'll turn to looking at some of the benefits of this new conception. Okay, good. So before I actually begin, I want to sort of engage with some preliminaries to sort of head off at the pass some potential misunderstandings of my project. First of all, my interest is in the scientific practice of scientific explanation. So I'm interested in what scientists actually do when they're offering a scientific explanation. So that'll be my focus. Second, it's also important to distinguish what's called a conception of explanation from an account of explanation. So a conception of explanation is a claim about what explanations are. So the two candidates that we'll be talking today are the ontic conception versus my Eikonic conception. This is different from an account of explanation, which is a claim about how explanations work, such as the deductive phenomenological, causal, mechanistic, etc. 99.999% of the literature on scientific explanation has been about accounts of scientific explanation. I am not going to be concerned with accounts of explanation here. I'll just be concerned with this issue of a conception. Okay. And then third, I also want to sort of just lay out at the beginning that I take explanation and understanding to be success terms. So my project is within a broadly realist conception of science. I do believe that there are ontic constraints on explanation among many others, but those ontic constraints do not require complete and accurate representations. And so in my other work, I've defended explanatory fictions, for example. Okay. Good. So let's turn to a little bit about the ontic conception. So the ontic conception was first articulated by José Alberto Cofa is reported here in Wesley Salmon's 4 Decades, where he writes, Cofa is a staunch defender of the ontic conception of scientific explanation. For Cofa, what explains an event is whatever produced it or brought it about. Explanations, in his view, are fully objective and exist whether or not anyone ever discovers or describes them. Explanations are not epistemically relativized, nor do they have psychological components, nor do they have pragmatic dimensions, end quote. And indeed, Salmon goes on to endorse this ontic conception, and he writes, explanations exist in the world. The explanation of some fact is whatever produced it or brought it about. Now, as it's been noted elsewhere, I think Salmon is a little bit confused about how to understand the ontic conception. He kind of wavers between two different ways of reading it. He's also a little bit confused about the contrast class to the ontic conception, because I think he hasn't clearly distinguished an account from a conception. So I'm not really going to be concerned with his version, nor Kofa's version of the ontic conception. And my focus will be on the more recent defenses of the ontic conception. So the more recent defenders include Carl Craver, who writes, and this is in his book Explaining the Brain, Salmon's most penetrating insight was to abandon the idea that explanations are arguments. Instead, he defends an ontic view, according to which explanations are objective features of the world. Objective explanations, the objective portion of the causal structure of the world, the causes and mechanisms in the world themselves are the correct starting point. Okay. And more recently, Craver has offered a nice, clear, I think, definition of the ontic conception in his 2014 paper, The Ontic Account of Scientific Explanation. He says, conceived ontically, the term explanation refers to an objective portion of the causal structure of the world, to the set of factors that produce, underlie, or otherwise responsible for a phenomenon. Ontic explanations are not texts, they are full-bodied things. They are not true or false, they are not more or less abstract, they are not more or less complete. They consist in all and only the relevant features of the mechanism in question. There is no question of ontic explanations being right or wrong, good or bad, they just are. Okay, so this is going to be the target of my remarks and why I think we need to move to the iconic conception. Now, Craver isn't the only one to endorse this, so Michael Strevens in his book Depth writes, philosophers sometimes talk as if explanations were something out in the world, a set of facts to be discovered, and sometimes as if it were a communicative act. I follow the lead of most philosophers of explanation and most proponents of the causal approach in particular in giving the first ontological sense precedence. From this point forward, I use explanation exclusively in the first ontological sense. Okay, so one might say that this has become sort of the orthodox conception, conception of explanation today. So let's just briefly summarize the key points here. I want to argue that the philosophy of scientific explanation took a wrong turn in going down the road of the ontic conception, specifically in their claim that explanations are the full-bodied things in the world. In this sense, we would say just are in the sense of are identical to the particular rock, the particular collection of testosterone molecules, the Sagittarius A-star black hole. These things are all scientific explanations. So it's important to sort of recognize it's not just the claims that these things are causes or causally relevant, but they are further scientific explanations. So on this conception of explanation, scientists and scientific theorizing are not in fact required for there to be scientific explanations. Okay. Now, something else that I think is important to emphasize is that although the people who have defended the ontic conception have also been at the forefront of causal accounts and mechanistic accounts of scientific explanation, one can accept causal or mechanistic accounts of explanation while rejecting the ontic conception. So these are separable views. And Bill Bechtel is an example of somebody who will endorse mechanistic accounts of explanation but reject the ontic conception. So these are separable, even though they've historically gone hand in hand. The people, I think they haven't quite realized that one can endorse one while rejecting the other. Okay. Good. So now what are some of the problems with the ontic conception? I'm sure you already have some formulated in your own mind. But one of the concerns is that ontic theorists have trouble talking consistently about explanation in the way that's true to the ontic conception. So if you really try to make them consistent, right, when it use the word explanation, you find that a lot of their statements become incoherent. So this is even true for Salmon's early work. So he says, according to the ontic conception, as I see it at least, an explanation of an event involves exhibiting that event as it's embedded in its causal network or displaying its internal causal structure. Now, this is something that people like Craver say should be de-emphasized in Salmon's account because, again, the ontic account is supposed to be about the entities and structures in the world. So he says exhibition should be de-emphasized in the ontic conception. And Corey Wright has a nice paper where he looks at Salmon's account in more detail and argues that there's no way of unpacking the exhibiting or the displaying that's consistent with the fundamental thesis of the ontic conception. And he argues that it's sort of leaving such terms like displaying or exhibiting unanalyzed, and by slipping back and forth between these ontic and representational conceptions, that is why the ontic conception has enjoyed an unwarranted success. Okay. So we see this also in Craver's account. So if we substitute explanation, I'm going to introduce the subscript ontic here, just to be clear what we mean by explanation, or what they mean by explanation, by which we mean the full-body causes and mechanisms in the world themselves. For occurrences in his 2014 paper where he's defending the ontic conception, again, we see it doesn't make sense. So he says the first project is explanatory demarcation. The theory should distinguish causes from other forms of scientific achievement. Cause is one of the many kinds of scientific success. Others include control, description, measurement, taxonomy. The second goal is explanatory normativity. The theory should illuminate the criteria that distinguish good causes from bad, and so forth. Okay, so again, I think they can't really consistently carry out this conception. The things that they want to talk about, things that all of us want to talk about as philosophers of science when we're thinking about scientific explanation, really don't make sense on a strict ontic conception. Okay, so they only make sense, I think, if we reject the ontic conception and see explanations as involving representations of causes in the world. All right. Good. Okay, so this is just as surprising that I think the ontic conception is only in recent years that people have sort of begun to sort of criticize it and raise some concerns, and it's sort of surprising that there hasn't really been clearly articulated alternatives either. So as far as some of the early criticisms, Phyllis Alari proposes to rescue the ontic theorists from this doublespeak. by shifting from a discussion of what explanations are to a discussion of constraints on explanation. So that's certainly a possible move. But it's important to realize that this is, a victory for the epistemic or representational view of explanation, because it only makes sense to talk about constraints on our representations, not constraints on the things in the world. So the question then is this sort of more circumscribed ground that the anti-conception is trying to carve out ultimately defensible? Benjamin Cherdos, in a nice, this was his in 2016, argues that it's not. So here's a quotation from his paper. He says, if we take the normative turn, the true task for the ontic theorist who promotes EEM, which is explanation to explanation mapping, is to make good on its conjecture of the normative priority of ontic norms, showing that whatever we mean by explanation, its full success must constitutively involve mappability to explanations sub-ontic. Okay, now Cherdos has argued that this is not possible. So even if we try to restrict the ontic conception to the priority of these constraints, there has to be this mapping from our explanation text to the explanation ontic in the world. He argues that some of the desiderata of explanation are generality and systematicity, and he argues that these can't be credentialed in the same way as particular explanations. And so he argues that because we value these things in explanations, it can't be credentialed in the same way by this mapping. Okay, so I'm not going to spend any more time looking at the criticisms. I've published on this in a paper, Fiction as a Vehicle for Truth, that came out last year in the Monist. So I want to try to turn now to articulating a positive conception. Okay, so just to wrap things up here, that first section, the ontic conception, I argue is not only incoherent, but I also want to say that it's not helpful or it's potentially harmful for the project of understanding scientific practice. So it leads us to believe that the particular way that we've represented both the phenomenon and to be explained, the explanandum, and the explanatory factors, the explanans, are the perfect and only way to represent them. Our scientific explanations are a function of the status of our scientific knowledge at the time and our standards of what constitutes an acceptable explanation, which, as the history of science, changes over time. So a full rejection of the ontic conception, however, requires offering and defending an alternative conception. I think this is something that hasn't yet been adequately done, and this is what I'm going to try to start to do today. I won't be able to complete the project, but at least to sketch it out. So the alternative that I want to introduce, and again, I think it's important to have a name to refer to this alternative to the ontic conception, I'm going to call the Eikonic conception, which comes from the Greek word eikon, meaning representation. So I'm going to illustrate it briefly with some examples from across the sciences and defend it as a better approach than the ontic conception. Okay, so let's turn to some case studies. I'm going to start from one from the history of science. So Thomas Chamberlain was the founder of the Journal of Geology. He founded the geology department at the University of Chicago, so an important early figure in the history of geology. And Chamberlain wrote this book, this article called The Method of Multiple Working Hypotheses in 1890. And in this paper, he defends this idea of multiple hypotheses. He says, in following a single hypothesis, the mind is presumably led to an explanatory conception. But an adequate explanation often requires, in following a single, the mind is presumably led to single explanatory conception, but adequate explanation often involves the coordination of several agencies. Such complex explanations of phenomena are especially encouraged by the method of multiple hypotheses. We are so prone to attribute a phenomenon a single cause that when we find an agency present, we are liable to rest satisfied therewith and fail to recognize that it is but one factor. Okay. So he wants to argue that we have this tendency as human explainers that once we find something that seems to account for the phenomenon, we sort of rest content and we don't recognize that there might be multiple hypotheses that can explain this. So he illustrates this with the example of an explanation of the origin of the Great Lakes Basin in the United States and Canada. So he says here, take for illustration the mooted question of the origin of the Great Lake Basins. He says it is practically demonstrable that these basins were river valleys antecedent to the glacial incursion, and that they owe their origin in part to the pre-existence of those valleys and the blocking up of their outlets. So this is one explanation. He says, so again, that it is demonstrable that they were occupied by great lobes of ice, which excavated them to a marked degree, and therefore the theory of glacial excavation finds support in fact. And then he says, continues, I think it is furthermore demonstrable that the Earth's crust beneath these basins was flexed downward and they owe part of their origin to crustal deformation. Okay, so here he's giving, now these were all considered rival explanations of the Great Lake basins in his time. And his argument here was sort of to reflect on this case of a scientific controversy and argue that really these aren't really competitors, they can all be legitimate explanations. Okay, so following Chamberlain's lead, I want to argue that when it comes to a complex phenomenon like the Great Lakes basins, what scientists typically do is carve off a simplified representation of that phenomenon that is appropriate to the tools of their particular subfield. So the fluvial geomorphologist, for example, is going to emphasize those features that indicate the ancient river valleys, and they're going to focus on this sort of representation of the Great Lakes basin. The glaciologists are going to focus on this kind of representation involving glacial scouring. And the structural geologist is going to focus on crustal deformation, and that these, in fact, can all be causal factors involved in the production of the Great Lakes Basin. Okay, so that's an example from history. I want to fast forward now to look at another example. This is from a conference organized by Bob, a wonderful conference at Pittsburgh in 2015. This is Nigel Goldenfeld. This wasn't the focus of his talk, but it was a particularly nice slide, so I asked him to borrow it for today. So he talks about how many different subfields of science investigate polymers. But what's important to realize is that the polymer that each of these subfields investigate is quite different. So the chemist is going to represent the polymer like this. And this is a representation that's particularly useful for answering questions about chemical bonding and reactions. Whereas the computational biologist is going to represent a polymer like this. And this is a representation that's particularly useful for answering questions about elasticity, large-scale motions, folding. And then half-jokingly, he says the theoretical physicist represents the polymer as a plate of spaghetti. And this is useful representation for thinking about thermodynamics, light scattering, and rheology, which is the deformation of matter. Okay, so we see that there is a plurality of representations of what a polymer is by each of these different subfields, and they choose these representations because it allows them to answer the sort of questions about polymers that they're interested in. Now, we also see this in the life sciences. So Helen Longino, in her book Studying Human Behavior, How Scientists Investigate Aggression and Sexuality, came out in 2013, shows how a phenomenon such as human aggression gets conceptualized or operationalized differently in different research contexts. So she explores how human aggression is represented and investigated in quantitative behavioral genetics, in molecular behavioral genetics, developmental psychology, neurophysiology and anatomy, and in social environmental studies. So she goes on to note that not only do each of these fields represent human aggression differently, but they also carve up the causal explanatory space differently. So she has these wonderful diagrams. I'm sorry, it's too small for you to see, but these boxes are the same. So this is what she calls genotype 1, which is allele pairs, genotype 2, the whole genome, intrauterine environment, physiology, anatomy, non-shared environment, shared intra-family environment, and socioeconomic status. So all of these boxes are the same. Now, the gray boxes are the sort of accessible causal space for explanations within that approach. So here's the causal space, and the blacked out boxes here are ones that are not investigated, right? It's not part of the causal explanatory space of that particular subfield. So here she describes quantitative behavioral genetics, and so this is the causal space that is a resource for explaining human aggression within that approach, but they don't deal with physiology, intrauterine environment, or allele pairs. If you look over here at molecular behavioral genetics, they focus on genotype 1 and genotype 2, but all of this is unexamined causal space for explanations. And then finally, this is social environmental approaches, and only the shared, non-shared environment, shared environment, and socioeconomic statics is the causal resources for explaining human aggression within those subfields. Okay, so again, I think it's important to realize how different subfields not only conceptualize a particular phenomenon for investigation, but how they carve up the causal space of resources for possible explanations for that phenomenon. Okay, now, and the conclusion, she says, I have surveyed 5 major approaches or families of approach to studying human behavior, but how behavior is understood as an object of investigation differs. It can be treated as a disposition or an episode, as a dimension of variation in a population among populations, or as an individual characteristic. She then continues on to say, many philosophers follow the scientists themselves in attempting to show that one or another of these approaches is correct or incorrect way to think about behavior. She says, I will argue to the contrary that each approach can provide a partial understanding of human behavior broadly understood. and that each can provide answers to the questions specific to it, but that certain features of the investigative space preclude their full integration or the elimination of one or more in favor of a single encompassing unified approach. Okay. So we've seen examples from the earth sciences, examples from a physicist, here from the life sciences. I'd like to add one more example of my own. So far I've been looking at examples that other thinkers have highlighted. I'd like to look at an example of a more specific concrete entity, because I think some people might, well, are we really talking about the same thing? So I'm going to look at an example where we have a multiplicity of representations even within the same subfield. This is going to be the example of water and chemistry. Okay, so you might be surprised to think that this is an active area of investigation. Indeed, it is actually a fraught area of investigation. Given the ubiquity and familiarity of water, this is perhaps surprising. Here we have a quotation from some chemists who are introducing models of water. They say, water is the most extensively studied molecule of unique importance to life, yet our understanding of how this deceptively simple compound of just 3 atoms gives rise to the many extraordinary properties of its liquid phase is far from complete. The complexity of the water properties, combined with multiple possible levels of approximation, quantum versus classical, flexible versus rigid, has led to the proposal of literally hundreds of theoretical and computational models for water. Hundreds, okay? Okay, so I'm not going to go through all 100, don't worry, but I'd like to take you through a tour. There's one particular model I want to get to, but I'll sort of take you down through the different kinds of models very briefly. Okay, so if we think at the most broad or general level, we can see that there are 3 general classes of models of water. So the first one are continuum models. So in a continuum model, we think of water as a continuous substance where the macroscopic properties are well defined down to infinitesimal volumes. So that's the continuum model, uses Navier-Stokes. We also have classical atomistic models, which are the familiar sort of ball and stick or ball and spring, tinker toys, if you remember from your chemistry class, classical atomistic models of water. And then finally, there are quantum models of water, which are hard to draw. Okay, so within each of these 3 broad classes, however, we can zoom in and see a plurality of models within each of these classes. So I want to focus in on the classical atomistic models for just a moment. So if we zoom in on that, we see that classical atomistic models of water can be further divided into 3 broad classes. There are rigid models in which there's a fixed atom position and only non-bonded. So we have a fixed angle here, fixed length. This only can handle non-bonded interactions. This is useful for explaining some properties, such as the high static dielectric constant or permittivity of water, transport through molecular channels. There are also a class of models that are flexible models. These are atoms on spring, where the water molecule is allowed to do these kind of funky dances. And then finally, there are polarizable models, in which they include a polarization term, which is important for explaining other sorts of phenomena. Now, once again, within the classical atomistic, we can zoom in on one of these submodels. So I'm going to zoom in on the rigid models to get a little bit more down to the one I'm interested in. And even here, we see a plurality of models of water. So within the rigid classical atomistic category, we find, and this is the non-polarizable, we find that there are different models. Here are the 3-site models. So this is what you would initially might expect, right? We have the 2 hydrogen and oxygen. So an example here is what's called the TIP3P model, have 3-point charges corresponding to the location of the atoms. There are more advanced models that are 4-site models, such as the TIP4P models. Here, a dummy atom represented by M is introduced with a negative charge to better reproduce the electrostatic potential. And then there are also 5-site models that have 2 dummy atoms represented by L here with a tetrahedral geometry. And then finally, there are 6-site models that combine the 4 and the 5 with the M's and the L's there. Okay, so we see a plurality of models, even within the subcategory. And then again, I want to focus in on one of these, the 3-site model, and I'll finally get to the one I want to talk about, which is known as the OPC3 model, optimal point charge 3-site model. So This is it was introduced by Saeed Azadi and Alexei Nufriev very recently. So they begin by noting that none of these 100 models can accurately reproduce all the experimentally well-known properties of water. So it's not the case that these are for prediction. We know what the values are, right? We know experimentally exactly what the values should be. The difficulty is coming up with a model that can reproduce those values. So they begin by saying that none of these can reproduce all the key properties of bulk water simultaneously. So this is the challenge. This is why we have so many of them, because it doesn't look like anyone can do the job itself. So what's interesting is they note here that improvements in overall model accuracy do not necessarily translate into improvements in the accuracy of quantities most relevant to biomolecular simulations. Counterintuitively, the TIP3P model predicts hydration-free energies more accurately than the more sophisticated TIP4P, model that fixed several of the earlier flaws. And then the more advanced one, the 5-site one that we talked about, which is known to yield excellent water structure, is even less accurate in that respect. Okay, so what they try to do instead is the following. They say the configuration of 3-point charges to best describe the charge distribution of water molecules can be very different from what one would intuitively expect based on its well-known atomic structure. So here we have a diagram. So here you have your oxygen, your 2 hydrogen nuclei, and what they note, so this is water actually in the gas phase, and what they noted is that the distribution of charges that most accurately captures the electrostatic potential is one in which the positive charges and the negative charges are clustered here in the middle. Now intuitively, right, as sort of this traditional realist, you'd think, oh, the pluses should be located on the H's and the minus should be located on the O, and the nuclei experimentally determine nuclei positions. But what they find instead is that by placing these point charges away from where you'd intuitively expect, they can better achieve agreement with the electrostatic potential. Okay, so this is why they call it the optimal point charge, because the idea is then to sort of abandon our intuitions about what the placement ought to be. And so they were motivated by the success of this model in the gas phase to see if they could do something similar in the case of the liquid phase of water. So, and this was sort of surprising what they came up with. So the OPC3 model is, again, optimal point charge. Let's put the point charges in the location that best captures this. And they were very surprised. Now, you might think, okay, well, maybe the classical expectations are wrong because we think maybe the world is fundamentally quantum mechanical, and so maybe that can explain this deviation. But surprisingly, it turns out that the quantum placement doesn't do better. And so this is sort of surprising. They create, so this is what we could think of as a quality map for the different water models. So here we have the TIP3P, the 3P, 4P, 5P that we talked about. Those are our classical models that are represented by triangles here. So this is in the dipole and quadrupole space, and then this is the quality score with the green. And they're looking at how well these models reproduce 6 key bulk properties of water. So they look at they say, okay, here, let's take some of the common models that we have available today. Let's see how well they reproduce these 6 key bulk properties. And then we're going to do a quality map for their score of how well they performed. So, of course, the optimal point charge models, the green, that's the best score here. These are the classical ones we talked about. But they were actually quite surprised in that the squares over here, these are the ones where the quantum calculation was used. And they are not optimal. So the quantum calculation did not, in fact, do better at reproducing these 6 key bulk properties. So they say, while the OPC moments are closest to the QM values, in particular, the quadrupole moments still deviate from the quantum mechanical predictions. The low quality of the test models in which the moments were close to the QM values suggests that within the 3 charged models explored here, an optimal fit of the moments to QM predictions, quantum mechanical predictions, does not guarantee agreement with experimental liquid phase properties. Okay, so I think this is actually an important point that's sort of been missed by philosophers of science. We often have this sort of naive view that the more realism we put into our model, the more realism we're going to get out, right? The more accurate our predictions. That there's sort of this monotonic increase. The more realism you put in, the better your model will be in reproducing things. But what we actually see in a lot of cases is that sometimes, once you're within a particular model structure, so the 3-point charge model here, in fact, sometimes you have to deliberately get things more wrong in the model in order to get the predictions more right. And Naomi Oreskes and I have a paper that's forthcoming, hopefully it'll come out this year, in which we talk about this sort of case that's widespread in the earth sciences. And this is true for physical modeling as well as for mathematical modeling, that sometimes you need to deliberately get things more wrong in the model. So in some sense, reduce the realism that you put in order to get more reliable inferences out of the model. Okay, so good, so let's try to take stock here. So, pace the onto conception, explanations are not full-bodied things in the world. Rather, I want to argue that explanations are an epistemic activity involving representations that are used to facilitate knowledge production and advance understanding. Representations are involved not only in the explanans, which I've talked about in my model-based account of scientific explanation, for example, but I also want to emphasize here that representations are involved in the explanandum. And I think that's something that's worth exploring in more detail. So scientists do not study phenomena in their full complexity. Rather, they study a simplified representation, as we've seen in these case studies of that phenomenon. And that simplified representation is contextualized within a particular field, research program, or explanatory project. This is in order to make the phenomenon tractable with the conceptual, theoretical, methodological, instrumental tools available to that subfield. So when scientists explain a phenomenon, such as one of water's anomalous properties, they do so within the context of one of these many possible representations. Okay, good. So I think we want to sort of recognize that some of these representations can do a better job of allowing scientists to answer certain kinds of questions. And there is often no one best representation that allows scientists to answer all the questions about an entity or phenomenon simultaneously. It's also important to recognize, especially from our water example that we examined, that what we think is the most realistic or fundamental representation does not always do the best job. Nonetheless, when these representations are appropriately credentialed, they can give us true modal information, such as the Woodwardian answering what if things have been different questions, they can successfully explain. Okay, so once we sort of recognize that representations play an integral role at the level of the explanandum, the phenomenon to be explained, the next step is then to try to articulate and explore what are the various ways that the explanandum phenomenon can be simplified in explanatory contexts. Again, I think this is an issue that hasn't received adequate attention. So I would like to turn to that now. Okay, so I think there are many different ways that an explanandum phenomenon can be simplified in different explanatory contexts. This is not presuming to be a complete list. I'm just going to articulate some of the key things that I think are important to consider, but I think there's more things that could probably be added. First, when a complex entity or phenomenon involves a number of different causes coming together to produce an effect, especially if the different causal factors belong to different subfields of science, scientists will typically focus on a subset of these causal lines and properties of the phenomenon as being the important ones to focus on. So we saw this in the case of the Great Lakes Basin explanation and the case of human aggression. Second, it's important to realize that an entity or phenomenon is represented at a particular spatial scale, which can lead to different variables and theories being explanatorily relevant. Certainly this is the case with the water example. But also, an entity or phenomenon is represented at a particular temporal scale, which can affect, again, which causal factors are important or negligible. So one example from the earth science is that if you're trying to explain the features of a cliff, if you're interested in doing that on a short time scale, storm events are going to be very significant, very important for explaining, whereas uplift is going to be typically negligible. But if you're interested in explaining a cliff on a long time scale, storm events are going to be negligible and uplift is going to be important. So what temporal scale you're interested in can affect which causal factors are going to be the most relevant for the explanation that you're going to offer. 4, we also need to recognize that scientists make choices about how the boundaries of the system of the entity of interest are drawn and delimited. Is a factor or process taken to be internal to the system and involved with it, or autogenic, or is it taken to be external to the system, affecting it only from the boundaries, allogenic? Number 5, a complex entity, or even a simple one, like water, can be ontologically decomposed in different ways, right? We saw the 3, the 4, the 5, the 6-point model. So it's important to think about the way that we decompose a system into its different components. And some explanations work better via a particular decomposition rather than another. 6, it's also important to think about the level of abstraction at which your explanandum phenomenon is represented. So there are many different levels of abstraction that we can consider. So if you think about, again, taking an example from the earth sciences, since that's what I'm working on these days, you might think about offering explanation for why rivers braid. So some rivers flow straight, some rivers meander, and some rivers exhibit this braided pattern, a number of interwoven channels. And, fluvial geomorphologists want to know, why do some rivers braid? They want to offer an explanation for this phenomenon. Now, when they try to offer an explanation for this phenomenon, usually what they're doing is they're trying to think about braided rivers in general, right? So they're trying to explain a particular abstract representation of a braided river, not particularly the Waimakariri River in New Zealand. But there's many different levels of abstraction at which we can consider. So we can think about, for example, we talked about braided rivers in general, but we could also ask the question, why do rivers with a significant amount of vegetation braid? And we can be even more specific, why do rivers with this particular type of vegetation braid? So it's important to think about the level of abstraction at which you're framing your explanandum phenomenon when you're offering an explanation. Okay, so I've talked about the different levels of abstraction at which we can explain something in my paper, How the Tiger Bush Got Its Stripes, if you want to look at another example of that in more detail. Okay, so I just wanted to put this in. So again, that list of 6 is not supposed to be comprehensive. I think these are some, the type of questions we want to ask about the explanandum phenomenon, that it's not just the thing in the world, that it's a particular representation, that there are choices involved. And I think we can see this as being very important even for mechanistic explanations. So I wanted to just briefly show, which is what Craver's primary concern is with. This is from Shimon Maron, who's, I think he's in the biophysics and physiology department at the Technion. He writes, quote, "We should be more aware of the abstractions made by an observer when measuring and reporting behavioral and neural timescales. These abstractions stow away the fact that observed and reported timescales are often not intrinsic to biological systems. Rather, in most cases, they reflect conditions that are imposed by the observer through the measuring procedure. This is true at practically every level of organization, from behavior down to molecules." Okay, so again, here we have a scientist saying that it's important to sort of reflect on the fact that even at the level of the observation, so this is what you were calling the explanatory facts, I mean, it's not what you meant by explanatory facts, but I think there's a sense in which we see representation not just at the level of the vehicle, but also at the level of the explanatory facts, and how we are observing or measuring or conceiving of those explanatory facts. So, and then here's Bill Bechtel, who writes, "Mechanisms are not sure." This is so Bechtel, in response to Maron's paper, is, I think, really starting to take this on as part of the mechanistic conception. Now, is this part of your 2.0, Mechanism 2.0, or I don't know from your PSA? So anyway, we can come back to it in the discussion. Mechanisms are not sharply delineated in nature. Explanations do not simply characterize mechanisms differentiated by well-defined boundaries. It is the scientists who impose the boundaries around entities and activities in nature and impose a time scale on which their functioning is characterized. For different explanatory purposes, researchers may draw these boundaries in different locations. Okay, so now it's not completely arbitrary where scientists draw these boundaries, but there's some flexibility and leeway, and it's important to sort of recognize the method, the decisions that we make when we're framing a phenomenon in a particular way. So this was just a slight detour to show that this is important for understanding mechanistic explanation as well. And I think the early mechanistic literature didn't quite recognize this. They assume that there's this, it's obvious what the mechanisms are, it's obvious what our boxes and our arrows are, and we just draw this, and it's exactly mapping onto the way the world is, completely independent of us. The ontic conception has encouraged that kind of assumption, and here we see scientists saying, no, we need to be aware of how our representational choices are not just reflecting what's there, but also reflect our methodological decisions in important ways. Okay, good, so we're entering the home stretch. So far I've tried to motivate the iconic conception by the shortcomings of the ontic conception, so arguing what are the problems with the alternative. I've tried to motivate it also by looking at a number of case examples from across the sciences for how we can see this idea in scientific practice. And I want to conclude now by trying to look at what I think are the philosophical benefits of the iconic conception. So first and foremost, perhaps, I think the iconic conception can help us better understand scientific practice, just like in the cases that we just examined. But I think there's a number of ways in which it can help us. One, I think we might start to see that there are really two steps in evaluating a scientific explanation. So here's what we think, an initial, is the explanation adequate to that particular representation of the phenomenon? That's usually what we consider. But there's also the question of, is that particular representation an adequate representation of the phenomenon in the world for the question that you're trying to answer? So there's sort of two steps here, right? One, is the explanation offered adequate to that representation? And second, is that representation adequate to the phenomenon in the world for the question that you're trying to answer? And I think that contextual part is important there. Also, I think we can see, and this was something emphasized by Chamberlain in the Great Lake Basin example and Longino in human aggression example, some, not all, some cases of scientific disagreement or competing explanations are only apparent, right? Is that they're not really in conflict with each other. They're involving different representations of the phenomenon to be explained. So there's still an open question about whether they're in conflict, but we have to be much more sort of nuanced in our evaluations of these scientific disagreements to see if there's really a disagreement there or whether they're involving different representations and whether those representations are adequate to the thing trying to be explained. Second, I think the iconic conception, unlike the ontic conception, allows us to talk normatively about scientific explanation, explanations being good or bad, adequate or inadequate, deep or shallow. Again, I don't think normative constraints make sense if we're just talking about the rock being the explanation. There's no normative constraints on rocks. But I think this conception allows us, and that's one of the primary things that philosophers of science are interested in, is in these normative constraints. Number three, the iconic conception, I think more straightforwardly allows us to talk and make sense of explanatory relevance. So it might be the case that explanatory relevance doesn't always track causal relevance. And so I think the iconic conception allows us to sort of separate those two things out, which might be important in certain cases. Number four, the iconic conception allows us to make sense of explanatory pluralism in the sense of multiple explanations of a given phenomenon. So explanatory pluralism is actually sort of a confusing phrase in the history of the philosophy of science. So explanatory pluralism initially was used sort of in response to sort of the Hegelian covering law to say there's multiple accounts of explanation. Explanation, scientists use multiple sort of ways of explaining things. They can use DN, they can use causal, they can use unificatory, whatever. So that explanatory pluralism used to mean that, but it has evolved, and today explanatory pluralism is more often used to describe the view that we can have more than one scientific explanation of a given phenomenon. And in fact, we might say there's type 1 explanatory pluralism, type 2 explanatory pluralism, and then type 3, which is that typically when we have more than one explanation of a given phenomenon, one might be causal, one might be non-causal. We might find that they're different accounts too. But okay, that's a detour. So this explanatory pluralism makes sense arising from the different ways that the phenomenon is framed in different research programs and the different accommodation contexts. So this is borrowing Dick Boyd's term from the Natural Kinds literature, the different accommodation contexts that can arise, so within a particular explanatory project, figuring out what representation is important for that, accounting for those phenomena. Fifth, I think the iconic conception allows us to better understand the role of mathematics, models, diagrams, idealizations, and fictions in scientific explanation. I've talked about those before. And then finally, number six, I think the iconic conception allows us to recognize the full range of constraints on scientific explanation. So as I said at the outset, I do think there are ontic constraints, but we need to sort of develop a more nuanced account of what those ontic constraints are within different contexts. There's some contexts in which the ontic constraints might be very strict, and other explanatory contexts in which they might not be. I can talk about that more in the discussion if you like. So there's ontic constraints, but there's also epistemic constraints coming from the fact that explanations should provide understanding. So this goes nicely with Arnon's talk yesterday. The point of explanation is understanding. Here I want to emphasize understanding the scientific community. And so that's the level at which I don't want to talk about it at the level individual or the ideal knower. I think there's kind of this ideal middle ground that we want to try to stake out here. And I think we see this reflected. So this is Eugene Wigner. So Eugene Wigner, when presented the results once of a large quantum calculation, remarked, "It's nice to know the computer understands the problem, but I would like to understand it too." And I think that's important to recognize, that explanations are important for us as human knowers, and so we need to recognize that there are epistemic constraints coming from that fact too. And then, as was mentioned yesterday, Angela Potocznik has emphasized communicative constraints. I want to broaden this out a little bit to say that we also see communicative constraints coming from the context of the inquiry, which determines which factors are explanatorily relevant for the purpose of that particular explanatory project. And so I think this iconic conception provides a space in which we can explore all the different constraints that might be relevant within a particular explanatory project. So that's all for today. Thank you.
So, questions? I don't know. Yeah, first.
I mean, I guess I have 2, 3. I hope it's. Tell me if I should stop. The first thing is about this kind of roles-like concept account, conception account. So I was just wondering, in the way, I don't remember Joan Rolls that well.
Yeah, I haven't, I don't either. So it wasn't supposed to be like his account.
So he makes a very, very similar, I guess, distinction then. So I wonder, but there it's supposed to, I'm just wondering, are these two ideas, is it completely orthogonal? What kind of conception I have of understanding, what kind of account? Like, in the kind of roles type thing, it's almost entirely orthogonal. Like we all agree that justice is...
Oh, so you're asking about conception versus account. Okay, yeah, and I think it's important to distinguish conception versus account. Because I think, I mean, as Bill Bechtel exhibits, right, if you think of Kramer exhibit, we have the ontic mechanist and a representational mechanist, right? So I think it's important to separate these two things. And I think the fact that they've been conflated and that the causal has sort of risen to prominence as, you know, one of the orthodox sort of accounts of explanation today has sort of brought the ontic conception along with it when it shouldn't have been. So I think it's important to distinguish.
There might be, you can distinguish, but there might not be, they might not be independent. And it might be that, you know, once you have a certain conception, then certain accounts are maybe ruled out. Or, I mean, so I'm not sure, but I mean, I think that's, so that's for instance a situation in the kind of roles like, you have a conception of justice, and then it can turn out on that conception that justice is, I don't know, you know, do whatever you feel like, you know, everyone's society should do whatever they feel like. That just doesn't exist.
Well,
that kind of thing doesn't.
Yeah, so I think that's, I mean, I think it's an under-theorized issue just because no one has really articulated alternatives to the ontic conception, right? I mean, I was just surprised that there hasn't really been a fleshed out, it didn't even have a name, right? Because there was, you know, this, epistemic, representational, you know, so there's kind of this vague, but no one's sort of taken it on to sort of put it forward in the way that Craver has, and, you know, Salmon perhaps, for the ontic conception. So I think we really need to articulate what these different conceptions are first. And then we could maybe go on to answer those sort of questions. But part of why I'm not feeling, so part of it is that I think it's been under-theorized what these alternative conceptions are. Second, I find the ontic conception so difficult to think of as coherent that I don't see that being much of a project at this stage, just because this idea of thinking of explanations as the thing in the world, every single thing in the world, every speck of dust is an explanation, because there's some phenomenon for which it is causally responsible, and whether or not we know it. And I think, to me, that just makes the notion of scientific explanation so useless that I don't know how to begin to, maybe I'm just being...
Okay, so maybe it's a related question. Well, I'm not sure if it's related exactly.
No, I think what you want to talk about is ontic constraints. Right? And so I think, and that's where I think the literature is moving. And so there I think there's lots of substantive philosophical discussions to have about what are the nature of ontic constraints, and in which context do we require something more like a mapping, and what context do we not require that? And I think there's lots to say there. Yeah.
So I'm wondering, so what would you say, so I'm not sure if this is, someone like Michael Strevens, for instance, which you cited as an ontic conception person, but I think in the book, he's very inconsistent about that, but that could be fodder for your mill. But but I think the way he would respond, and I'm pretty sure this is the way Craver would respond. I mean, at least he's sort of sent this to me several times. Is that, well, look, almost everything you say can be packed into how we characterize the explanandum, and that is, by all accounts. Here I'm trying to voice a kind of Craver-Strevens view, right? By all accounts, that is a very context-dependent, interest-relative, so on manner, right? Because it's really a reflection of, you know, what we want to understand, what we want to explain, what puzzles us.
See, I think, yeah.
They'll say, but, and this is the crucial point here for them, once you fix on an explanandum, the rest is object. Now we can argue whether it's exactly facts or representations of facts and so on, but it's fully objective. We don't need all this relativism once we've fixed on an explanandum. And so in the case, for instance, of Maron, which I love, that paper I think is like just mind-bogglingly good, he basically says, look, the problem is that explananda shift, right? So the problem there is the argument there is like there's no characteristic time scale for the action potential. And the reason is that if you want to explain a single action potential, you need to look at hundreds of milliseconds. But like if you expand somewhat on the scale of minutes, then so on. Craver can and has in fact said about that paper, look, I mean, he's right, but it comes from the desire to sort of understand different phenomena. Fix on a phenomenon, the rest is objective, the rest is context independent.
Okay, so the way I understand what he's saying about that is that he's saying just what thing in the world we pick out is interest relative, right? But I don't think he's quite fully taken on board the idea that we can represent, once we pick out the phenomenon in the world, there are different ways that we can represent it. Now, part of where I'm coming from this is that he and I have sort of gone back and forth about explanatory, whether fictions can be explanatory, right? And he thinks it's just crazy that fictions could explain. And I think part of our disagreement comes from that we have these different conceptions. And so if we think of it as already as a representation, then we have room to think about how accurate that representation has to be, and we open up the space for fictions explaining. If you think of explanation as the thing in the world, there's no room for fictions to be explanatory because fictions don't exist, right? They're not in the world. So that's sort of where I see the disagreement coming. And he's going to say, look, if you're going to explain the chair, explain the table, explain the wall, that's interest relative, but it's the thing in the world. And I want to say no, that there's already representation choices, not just choosing between the chair, the table, and the wall. That's interest relative in the sense he wants to say, but also how we represent the chair. Right? There's going to be different ways that we can represent the chair. And I don't think he's quite taken on that second step fully yet.
But isn't that, so I'm just one last question. So this is, right, so you have to just go to finer grain, you would say, like, sure, we're all representing the chair, but I'm representing its rigidity, whereas you're representing its, I don't know, its construction. And so we're representing completely different features of the chair. So you're going to go for an historical sort of teleological explanation, whereas I'm going to go for a sort of a physical explanation. I'm just wondering what you say in response to that.
Yeah, so it's not just sort of the different features, but it's what you want to do with it, right? So the rigid features can appeal. So think about the water model, right? They're trying to explain the same 6 properties, right? So it's the same properties they're picking out, but there's different models that are ways of trying to do that. So it's not just a matter of you choose these properties, I choose those properties, but even when we sort of said, okay, we're trying to understand these 6 properties, there's the question about how to represent the thing in order to explain those 6 properties.
So to me, it just seems like those are the cases that are genuine objections, like strong objections to flavor.
I did the water case because I didn't think the other ones were strong enough. So I thought this was a stronger case because it was a clearly well-defined entity within the same subfield, the same properties we're trying to pick out, and we still have a plurality of representations.
Just one thing will be a follow-up, and another is I will try to defend Prager a little bit. Although one thing is clear, I really like to talk about representations as involved in explanations. I think this is the right way of doing this. But I don't think it's totally orthogonal to the question of what is your conception, because we have covering law, a kind of explanation. Thinking of it in terms of ontic view makes little sense to me. I mean, the arguments are not there to be picked. I mean, this is the argument. You cannot have the ontic conception. So some accounts will be definitely excluded. So some are not. But the other point is that I think you were too quick to dismiss that you cannot use the notion of constraint in the ontic conception. You can, and if you look at 2007 book by Prager, he has a very nice chapter there on constraints, and the constraints are not on the actual reality, it's on the space of possible mechanisms. Now, you're talking about the space of possible mechanisms. I think it's clear that you're not talking about the space of representations of mechanisms there. So he thinks that if you know something about a phenomenon already, or then you could exclude part of the space, and then you somehow, by searching the space, you find the candidates for the explanation.
Okay, so I didn't claim that everything Craver said was crazy. But the point is, I think when he's talking in a coherent way about explanation, in an interesting way, the kind of ways that you were just mentioning, he's implicitly endorsing a representational conception of explanation. And so what I want to be pointing out here, though, is that he slips back and forth, right? So when he's talking about normative constraints, he's talking about the choice of how to represent the mechanisms. He is implicitly endorsing a representational, something like this iconic conception. He doesn't realize it, though, because he's out there with his 2014 paper talking about the ontic conception. So what I'm trying to do is sort of push him on this to sort of recognize that tension, and that we should just go with the sort of things that he says when he's being coherent and abandon the ontic conception.
I don't see any incoherence here. He speaks of explanatory texts in the book all the time, and what he simply means that explanations are truth makers for explanatory texts, so you can switch.
But he said all that's downstream from explanation, right? And so, I mean, like I was saying to Arnon, I think, part of what motivates us is that he doesn't he has trouble dealing with idealization, with fiction in these models and explanation, and his resistance to a lot of that, I think, comes from his implicit, or explicit in this case, endorsement of the ontic conception. And I think if he were really to sort of think that through fully, then he wouldn't have he wouldn't say, that's not a problem for explanation, that's all downstream. No, that's a huge problem, right? To understand how idealized models can still explain is the heart of what we as philosophers are interested in explanation, right? And I think he tries to bracket that and not engage with that because he's holding on to this ontic conception. And I think we start to see him move. So I think the 2014 paper is interesting because Phyllis Solari's objection came before it was published, so she had an early draft of it. And you see in that paper, he keeps switching back and forth. And I think he just hasn't quite fully brought it into resolution yet. And so what I would want to encourage him to do is just leave behind the ontic conception, let's recognize it as representation, and then we can start to talk about whether idealizations and fictions can be explanatory and why not, and so forth. But I feel like I have to sort of clear that space first, because right now it's hard to have that conversation if you're holding on to the ontic conception.
Yeah, but some of the constraints that he mentions are clearly not the ones that are merely representational. So he thinks that you bring some temporal scales, temporal phenomena, and these simply are just descriptions of mechanisms out there. Mm-hmm. So you can use a representational talk on this, but it doesn't change anything. You still describe objective facts.
That's the Maron point.
That's the Maron point, yeah.
That's why.
Yeah.
But it's the very same phenomenon that he's targeting.
Yep, exactly.
So it's consistent to talk about constraints when you have the ontic conception. So your point was to put...
No. So the idea is that representation is involved in the very observation and measurement of the phenomenon, already at that stage.
But where does Prager says that phenomena are not representations? He accepts Bogan and Woodward's view to say that these are actually representations. Exponential phenomenon is not out there. It is related to our interests, so I don't see how the Eikonic conception is better.
So the ontic conception says that explanations are the things in the world, right?
Yeah.
And my concern is that by identifying scientific explanation with the things in the world, it assumes, and then he has this explanation mapping, which assumes that we can the representation is just going to be a faithful, right? Perfect reproduction with no question, right? And that's what I'm trying to challenge, right? That we need to realize the way that the explanatory context, the subfield, all these things come in, the choices that we make in measuring and observing, this all comes in to shape that phenomenon. So it's not just the thing in the world. And if we think of it as just the thing in the world, it's sort of, I don't know, like it's almost like a hubris, right? I mean, I think we need to learn, and I think this is kind of the lesson of some of this work, we need to learn about how it's shaped by our interests, our projects, and so forth, and that we need to realize then it's subject to change, right? If you study the history of science, you sort of realize, we need to be aware of ways that might change. And this ontic conception, it's just the thing in the world, and it's perfect mapping, and that's the end of it, we're done, right? That's set for all time and all projects and all so forth. And that's what I find problematic.
Sorry. Oh, yeah, thanks. That is very nice, thanks. Especially the stuff about water, so I'm particularly interested in water.
Good. I think I'll drink some right now.
Yes.
Cheers.
I have a paper, why does water boil? So, so I probably echo what has been said already. So I think that, so I'm not defending the ontic conception.
Good.
But I think that that most of what you presented as characterizing the iconic conception, they can take it on board, right? So I'm not an expert in the ontic conception or anything, but I think that they would accept that phenomenon or sort of give an underrepresentation and all that. I mean, that's and I mean the question I have though is where is, I mean, just to try to get a grip on what's the difference between the ontic conception and the iconic conception. What is the place, or how does understanding come in the iconic conception as opposed to the ontic conception, right? Because for the ontic conception, the story, the way I understand the story is this. Well, to understand the phenomenon under representation, I'm going to give them that, is to basically be able to trace back the causal path, right? And this is something that is out there in the world, right? And you basically, as an epistemic agent, you trace that path. Once you have been able to trace that path, so maybe I guess that's a way to make sense of that crazy idea that explanations just are, right? I think it's very badly put, but it's probably something that's in the mind of Prague or whoever that was. So there is a path, there is a causal path, and to understand the phenomenon is to be able to trace that path from the cause of that phenomenon under representation to the phenomenon, under the representation. So to trace the causal path, right? And that's objective, that's everything, right? Now, what does the Eikonic conception has to add to this?
So it's first of all to say
I think that's very problematic, but maybe, yeah.
So part of it is that to say we can still accept causal explanations. But in an explanation, what we're doing is we're selecting out. We're representing the causal features in a particular way, representing the causes. We're selecting what's going to be relevant to our explanatory project. We might pick out different, as I said, with different time scales. We might pick out different causal factors as being the important ones. And so we need to realize that we're representing the causes, right? And that it's not just the thing in the world, also because of this potential that it might be updated with more information as we go forward, right? So I really think it's important to think about how we're representing the causes. Also, because I want to open up the space, that sometimes we can think about sometimes it's important to think about explanations in which we might represent the causal factor in a way that we know is not exactly right. So in the paper, Fiction as a Vehicle for Truth, I talk about the case of the explanation of the tides. And if you look at physical oceanographers, right, they explain the tides in terms of Newtonian gravitational forces. Now, the gravitational force is a fiction. It doesn't exist, right? But if you look through the entire journal of physical oceanography, you will never once see a reference to space-time manifolds, stress-energy tensors. There's no graduate physical oceanography program that requires general relativity, right? So, and I want to say that the physical oceanographers genuinely explain the tides, but they are representing the cause, right, in a fictional way, as a force. Okay? Now, and I want to say that's legitimate. Okay? And I think, oh no, they're air forces. They don't exist in the world, so you couldn't do that. You have to do this. I want to say that no, they genuinely explain. And so I think there's lots of cases like that where the true veridical representation as we understand it is not necessarily, maybe we can't explain the tides until we have a quantum theory of gravity. I mean, hello? So I think this just gets absurd, right? That we need to make this distinction between, even in a causal explanation, the thing in the world and our representations of it. And sometimes we can choose to represent it differently because that's more useful. So the phenomenon that physical oceanographers are interested in, they don't need the general relativistic conception, right? They are interested in how different forces come together, about how the depth of the ocean and the land masses and all these sort of things come together, and the force representation is the best representation for answering those kind of questions.
Yeah, but the trigger would take this would say that a lot of things are not relevant to your explanation at hand. So you should restrict your if you.
No, but see, he talks about different. So if you think about the difference makers, right? I mean, so if we think about using that's Trevin's language, but so the idea is we're in the case of the gravitational force. Okay.
The way you put it, it seems like any fiction would do. So let's.
No. If you read my paper, it's a credentialed fiction. I spend a lot of work. Not any fiction will do.
Of course.
The scientific community has to credential.
Can always say that some of the things that you would have from general relativity for with those people who study tides would be some noise. You don't want to talk about that. Because that would make the...
Okay, so I think it's important to make a distinction, because sometimes we have lots of causal... let me just try to answer your question. I know your question, so let me try to answer it. So one is we have lots of causal factors coming in, right? So the way that Strevens talks about it is we don't need to tell, like, breaking of the rock, we don't need to start at the Big Bang and trace the causal story and talk about this blow of wind and this person sneezed in the park next door. We don't need to do that. We focus on the difference makers, right? So I think that's where your question is coming from. But there, that can still happen within the object conception that we focus on, and this is what I think Strevens and Criver have in mind. We focus on just the causal difference maker. So we're picking out certain causes, but they're still requiring a vertical mapping of a vertical representation of the causes. Now, what I want to say in the case of the tides is that it's not that we're just ignoring some other causal factors and picking one causal factor. We are taking that causal factor and representing it fictionally, and that is legitimate. And Newtonian gravity is a credentialed fiction. Now, so Strevens has this thing, with Newtonian mechanics, so for him, understanding is having a correct explanation, which has true propositions, and so he has this account. And then he says, so we can't really understand with Newtonian mechanics. The kind of understanding of Newtonian mechanics would be the way the world would be if it were a Newtonian world, understanding with, and so he makes this distinction. I think that's nonsense. We still teach Newtonian mechanics because it teaches us about the actual world. Okay? And so I want to say that we're actually learning, when we represent things with Newtonian, we're learning about the actual world. Now scientists who use this fictional representation know that this is not the fundamental theory. They know that, right? They know general relativity happens, right? But that's not the appropriate representation for the kind of questions they're answering in physical oceanography. So it's not just a selection of the causes. It's actually representing the causal factors in a way that we know it's not, because that's a credentialed representation that does a better job for the kind of questions we're trying to answer. Sorry.
Okay. I have just a couple. I think that's really great. I disagree with you to some extent about the fictions and the representations, but that's sort of not really the point. So, in the water case, it doesn't seem terribly surprising that one models wouldn't be that accurate because, right, Planck's constant doesn't really play much of a role on the scale in which you're looking at the thing. So you could tell a story like that, right, to explain why.
Right. The odd thing is just our classical intuitions failed, the quantum ones failed. Right. So it kind of shows that we're in.
No. It's a great example. It's good, but I think there are things that you can say about, it's often the case that quantum mechanics doesn't get us what we want.
Right.
Because as you written a book about it,
right.
We're often in a domain in which.
Right. It was just anticipating this objection. Oh, well, why would you expect the classical picture? Maybe it's the quantum corrections, but I was trying to point out that wasn't right. Yeah.
The other thing is, I think that Bechtel responses goes a little too far.
Okay.
And I don't think you want to buy into that. I mean, it's not just the scientist who imposes.
No. Yeah, and in fact, he goes on a little later to try to. He says it's not completely arbitrary, but I think you're right that we want to push back that there are ontic constraints. So I would agree.
Right. So this is why I was talking to you about my student who's working on, identifying the target in modeling is just as important as trying to figure out what the model is and how it relates to the target. And so there are dominant behaviors that
absolutely
that are recurring, repeatable, etc. And it's not surprising that we're interested in those things because we run into them all the time.
So I did not intend this as a sort of constructivist position. I tried to say I was within a broadly realist. So there absolutely are constraints. Very realist, very much constraints. We can't do anything we want. So when I've talked about fictions, and I think this kind of gets missed sometimes, is that I'm talking about credentialed fictions, like semi-classical representations. I need to be more careful. Yeah, I just actually added Bechtel because of Arnar. So.
Thanks.
I disagree with you too.
Okay. Well, did you do that? I thought your PSA paper was Mechanism 2.0 that you co-authored with him, right?
Sure.
Okay.
I hope you moderated that view to bring it to where
Okay.
more or less it is.
Yeah. All right, good.
Yes, thank you, Professor. I just wanted to, I agree with you that the Anthony account is completely consistent and completely on board with that. I just wanted to try to cash out the account a bit differently to make it look more plausible. So maybe what they are after actually is it's related to the analogy between logic and like how to convince people is explanations are as abstract objects. That's what they should say, actually. They should say there are explanations out there in the world, they are abstract objects, and they are intemporal, untemporal, they're always going to be there, they're always going to be there, and the project is a normative project, is to find out about these abstract projects in the world. I guess that would make sense of pretty much everything they are saying, except that they wouldn't like that because, I mean, they maybe don't want to say the explanation.
So, I mean, Sheridos sort of explores a little bit. He's like, so if we have the explanations being of general, right, and not the concrete example of it in the world, then he says that commits them to kind of a universalism, right? And then he says that that's kind of an odious metaphysical position to be driven to, and maybe you would have independent reasons, but it seems odd to be taken to that position through this route. And it's really not a route I want to go. I'm trying to understand scientific practice, and so I'm trying to keep it grounded in how scientists think about this, and that's where I'm seeing that scientists can represent phenomena differently. It's empirically informed, it's empirically constrained, but we need to recognize there's still a plurality of possible representations. And they are, I mean, I want to also emphasize how scientists actually learn more about the world through a plurality of representations than with a single one. We kind of assume, realism requires we have the one true, accurate depiction that captures everything. And I want to say no, that we actually get more realism out through a plurality of representations that allow us to make more correct inferences. And that scientists are very good at this, about knowing which representation to use in which context, knowing the limits of that, or at least investigating what the limits of that representation are. So it's something that they use very consciously and carefully. And I think, that's the practice I want to try to understand.
I agree with that. I just think it would be maybe more fruitful to have as an opponent more plausible accounts. But of course it's not there, but it seems that they're just equivocating between the causes and the causal facts, and that they are after the causal facts, and that this is what they should call explanation, and we should recognize that they are after abstract objects. Even if they don't like it.
Yeah, I don't find it a helpful way to go, but okay.
I don't know.
Yeah, I guess. Never mind it.
Over drinks tonight.
Yeah, so I just okay. No, I mean, I wanted just like a footnote to mention the unificationist conception or account, I'm not so sure. Because they don't talk about causation at all, and they don't talk about causation on purpose because causation is metaphysically a mess, and therefore would not add, would rather muddy the waters rather than, clarifying anything. So if you want an alternative to the one thing, I personally would go with the unificationist conception. Of course, there are problems. Yeah, account. I'm still not entirely clear on how you distinguish.
What explanations are, how they work. I think it's
so
there might be connections, but I think it's important.
The unification is to tell you what an explanation is. Is a you know the story. It's a derivation from within a So and.
But a unification is a thing in the world. I think we want to.
No, it's not in the world.
Right, that's the thing.
So maybe it's toward the icon.
In Kitcher, it's very clear. He very clearly says that, look, if you think that explanations should unify, then you need to move to what you're calling a different conception.
Yeah, exactly.
And that's why I'm happy to say there's
So
connections.
he thinks that the connection, though, is very close.
Okay, so I think it's the causal account of it, and the mechanistic account of explanation that this distinction is very important. I want to at least put that out, that there's a conceptual distinction which is very important in some contexts, maybe less important in other contexts, but I think I find it helpful to distinguish these two things.
Okay.
So, one last
Very, very short question. It's a partially joke, partially serious, but if you have something which answer both questions, whether how explanations are and how they work, what do you call this thing, a conception or an account?
Yeah, I know. So, I think I like to focus on an account. So my prejudice. My prejudice is that everybody should be an iconic. have the iconic conception, right? That we should just think of explanation. But now people have explored what maybe there are alternatives I hadn't thought of, and so I don't want to close off that. But I think explanations should all be put, the right conception is the iconic conception, no matter what your account is. And so I would move to that direction, and then we can talk about the unificationist and the representations involved there, we can talk about the causal and the representations there, and whatever the other versions might be. But that's my prejudice. So, like I said, this is under-theorized, right? I mean, I think it's because people have conflated account and conception that the object conception has been the only game in town, right? And so I think, it's worth exploring what these alternative conceptions are. And the iconic is maybe just one. I don't know if there are others. I haven't done that work yet, but I would encourage people to think about it.
Okay, well, thanks again.